Denis Garand. I'm professor in entrepreneurship and small business management at Laval University in Quebec City. We are involved in a pilot study that will be developed in Canada within the next 4 years. Pilot study to develop entrepreneurship in genomics, entrepreneurship behaviors, entrepreneurship competences, entrepreneurship potential within the scientific researchers, to let them understand that they can do something with their ideas, innovations and discoveries, something that might bring them towards a better fitting the market needs of the society and being involved in more commercialization of their innovation and discoveries. So this pilot project has been launched this fall by Genome Canada. We will be doing first an inventory of all researchers in genomics to better understand who has the potential, who already is an entrepreneur, who already is an intrapreneur. Those people that are salaried within an organization that have entrepreneurial behaviors and usually don't know it themselves. So we will help them develop these potential to first being able to respond to market needs that will, or opportunity recognition, and then move their ideas into projects that they do in teams, projects that we will coach and monitor with a team of venture capitalists, of technicians in commercialization and marketing, to help these scientists become one day or another closer to the market and closer to real product, processes, treatments, and obviously medication someday, using genomics to better serve the needs of society. So entrepreneurship has to be developed in the society, and it takes years, it takes many years to develop, and we will make sure that this thing is starting as soon as we can, because Canada is actually lagging besides Japan, United States, and many European countries in terms of really moving scientists into entrepreneurial endeavors. Scientists are usually working in their lab and research centers, and we need to help them become more aware of the potential of their innovation and discoveries for the society at large. Obviously, politicians are aware of these necessary outcomes, but they don't easily understand that it takes more than 2 or 3 years. Developing entrepreneurs usually take 5 to 10 years. Developing innovations in genomics and bringing them into commercialization takes 6 to 12 years. Okay, so we have to start. And many people say that we are actually lagging 10 years. So if we don't start right away, we'll be behind everybody else in 10 years. So that's why this thing is so much important. Entrepreneurship education in genomics has to be really speed up to make sure that we will obtain results and through outcomes as soon as possible. So within this Best in Genomics project, we have hundreds of scientists that we will bring into the project with what we call embedded and symbiotic tools and training tools and coaching to help these people develop their ideas with our support, with the support of the people that will be involved. So I have here an end user which is called Franz Lang from Université de Montréal in Montreal, and he will be able to tell you what he has actually as discovery and innovation, and how he will integrate himself into the Best in Genomics pilot study as an example of what we can do with these scientists to bring them closer to commercial outcomes.
So my name is Franz Lang from the University of Montreal. I am the leader of a project on the genomics project that targets the bioremediation of polluted sites, both sites that are polluted with organic chemicals, for instance crude oil or toxins, as well as heavy metals. Our approach is an approach that is not new. Industry is already using plantations, so plants for phytoremediation. They're also using microbes for phytoremediation. What we are trying to do is, however, do the integration. We try to use a chain of plants, microbes of all sorts in order to optimize this project. So in a way, it is an acceleration of what nature would do by itself, but it might take nature 100 or 200 years. And when we put the right components together, then this can be done maybe in 2, 3, 4, 5 years. So I mean, the problem is acceleration of this process. And it is very important for this purpose that we collaborate with industry, because industry has the polluted sites that we can use as a model and also as a playground for our experiments. And this is one of the incentives why I was very interested to hook up to Best in Genomics, which is trying to foster commercialization, so making contact with industry, because for a scientist it's very difficult to actually grasp a world that you are not grown up in. So you have to actually learn how to go about surviving not only in academia but also in a true business world. So I'm spending actually quite a bit of time to relearn this type of expertise. And so currently what we've done is we have been starting to isolate fungi that eating up crude oil from the Albertan tar sands. And so the first experiment we've done, we have been very successful in finding certain fungi that within a couple of weeks actually eat up tar from those tar sands, actually mineralize them to virtually air, CO2 and water. So there's a demonstration on this table where you can actually see all those experiments. It's preliminary, but I mean it's very exciting because we started in July this year, and I think within 3 years, which is not a very long time, but I mean it's something, we might actually find already during this process of this research process, we might actually find technologies and microbes that could help right away to install on industrial sites and try to find out solutions in real sites. So industrials might actually be interested to grab onto this right away and invest in what we are doing.